I am Mai. Hello everyone. Hello teacher and everyone. I am Mai, and today I will talk about the lab one, how computer handle a program. Firstly, there are some content that we have to acknowledge before move to the CPU Sim4 application. The first one we will should talk about with the computer architecture. In this part, we have to explore uh, what is the memory, what is the central processing unit, and what is the I/O system. But first of all, but as and especially we have to especially is the central processing unit, which stand for CPU, which is CPU. Okay, and the next thing that we have to discover about is the instruction execution process. And we will talk about the instruction and the instruction phase. And the last part and the most important part right here is we will do in the lab. We will do the lab with the CPU C4 application. Okay. Okay. Now let's get started with the first one, computer architecture. Okay, the architecture contain of two concepts. The first one is the instruction set architecture, which include the instruction set and the data type. And the second concept is the computer organization. You can take a look at this picture right now, this diagram right now. You can see there are the system, the I/O system. Here is the memory. Here is the memory. And here is the CPU. And more about the CPU, we will talk later. Now let's move to the detail of the component. And I say just a seconds ago, there are central processing unit, memory, and I/O system. Okay, let's move to the detail. Let's move to the detail of CPU. Okay, CPU, you can take a look at this picture. No, before that, we have to talk. We have to know what is the CPU, right? The CPU, also called a central processor or main processor, is the most important processor in a given computer. Okay, the most important processor. Yeah. And the second thing is excused instruction of a computer program, such as arithmetic, logic, controlling, and I/O operation. Okay, remember, it's a skill instruction of a computer program. Okay, and let's take at the diagram, the model. You can see there are register, ALU, internal bus. Right now, or okay, about this, we won't talk about the internal bus. We will talk about the three rest of them. It is the register, ALU, and the control unit. Okay, about the detail of the CPU, we'll tell the control unit, always called CU, is a component of the CPU that direct the operation of the processor. Remember the direct the operation of the processor. You can simply understand it like a person, a staff that use some equipment in the company. And the equipment is some other unit like ALU or register or and memory. Yeah, and the control unit here is the staff will put the data into the equipment and wait for the result and again put it into other equipment to get the last product, right? You just it's a easy to understand example. And the next thing the CPU do is tell the computer's memory, arithmetic, and logic unit and I/O device how to respond to the instruction that have been sent to the processor. Okay, remember respond to the instruction that have been sent to the processor. Okay, but just remember direct operation of the processor is okay. Um, Here is the register. The register, let's say before, is a contain used to contain the uh, temporary data that the CPU will use right away, or is help the CPU uses the CPU take it as fast as it can. I'm not sure, but it's just is used to store the temporary data for fastly execution. Just yeah. And there are some type of CPU register. There are more. There are more concept than this. There are more type than this. But today we just acknowledge these four, which just we just need to acknowledge these four, and some other I will talk later. But they say okay to use for the last session of us in working with a CPU SIM4 application. And here we have the program counter, the keep track of the memory address of the next instruction to be fed and executed. Okay. Just remember keep track of the memory address. As its name, the counter, like the pointer. The pointer point to um the the next skill we do. Yeah. The next thing is instruction register. Host the currently fed instruction being executed. Okay, simply understand it as a uh, register used to store the instruction. And the next thing is accumulator. It's a general purpose register used for arithmetic and logical operation. It stores intermediate results during calculation. Okay, what is intermediate trung cấp ở giữa in between. Okay, you can simply understand it as a variable, a unit which is used to store some variable or some data. Yeah, some variable or some parameter. Yeah, like operand or yeah, to store something. Yeah, and the general purpose register are one or two or n are used to store data during calculation and data manipulation. They can be accessed and utilized by the programmer for various purposes. Okay, this one will store a lot of things like operand, as I said before. Yeah, I will talk more about this later when we use the CPU SIM4. And accumulator, you just simply yeah, it's also they are kind of same as each other. Okay, the next one is the ALU, which stands for the arithmetic logic unit. It's a digital circuit within the processor that perform integer arithmetic and bitwise logic operation. Yeah. Okay. End of the CPU's concept. We will move to the memory. And now we will talk about the memory in internal memory, which is main memory or primary memory. It used to store current data, programs, and instructions that can be accessed quickly while the computer is running. Yeah, as you know, there are RAM and DRAM. Yeah, random access memory. Okay, here is structure here, right? Yeah, look like this. Data and address. Okay, the last one we talk about is the I/O system. The I/O system is used to exchanging the data, input, output, and some of its component is the peripheral devices, I/O module. Okay, and that's the end of the computer architecture session. Now we move to the second session, instruction execution process. Sorry for the grammar of the title. I just don't know how to express this, but I know that you will understand this. There are, there are three concepts that we have to acknowledge. Instruction are instruction operation of CPU and instruction phases. And now move to the first one. Sorry for the picture. It just I forgot to remove it. Okay, the instruction consists of two parts, the opcode and the operand. Instruction or instruction sets is used to control the computer. The instruction sets we use it in this in this in the next session is MIPF. Or just forget about that. Okay, the second concept is function of CPU or CPU's operation. There are three there are three functions of the CPU: skew, interrupt, and input output. There are passive function of CPU: stop when there is stop condition or else. Okay, interrupt allows CPU interrupt to execute another program. And IO stream that you know. And the next one is CPU's operation. There are three main steps, but here are four steps. Here are four operation, but it's okay. Um, okay, we have okay, phase is cycle. Phase is cycle, but I don't remember the word, but it's okay. The first one, the first in operation is will fetch the data and the instruction. That's really called the instruction to the command, and then it will execute the command or the demand. And then last one is will store the result. And it's just happen in a loop until there is a stop condition. Okay, here instruction phases, or we can call it instruction cycle. More detail about it. Let's take a look at here. We have here is first instruction, the instruction. Yeah, as we know. And about the execution, we will have let's take a look at this. ALU operation. Access memory, update register file, and the last one is update the program counter to do the next instruction. Okay, here is a detail, more detail than this. We will talk about this diagram. The stage 1 to the stage 3 is in the fetch phase. Okay, first the program counter will push its data to the MAR. The MAR, which is stand for the memory address register, and yeah, which contain the address where we will take the data, and then the PC will increase. Okay, this actually will happen at the last, but it's okay. We just simply understand that this is a top of the program counter, but it's actually I don't know, it's not in the right location right now, but it's okay. The state two is the CU will take the data in the main memory at the MAR address. Okay, at this address in the main memory. Take his data and push to the MDR. The MDR is stand for memory data register, which store the data. Okay, MAR store the address, and MDR store the data. At the state three, the MDR will pass the instruction to the instruction register. Then we end the first phase, fetch. At the second phase, we will decode the data in the instruction register to the output. And there are a lot of demand, but there are some example like add, LDR, and jump. Then this will execute the demand. This will execute the demand, and when it's done, let's come back to the first stage. First stage, and redoing it in a loop until there is a stop condition. Okay, now it's done about the instruction phase. And now let's move to the last system. Uh, working with the lab one, working lab one. Lab one working with the CPU C4, sorry, CPU C4 application. Now let's open the CPU C4. Sorry, my phone is out of battery, so I don't have anything to record myself right now. So I'm sorry for this, but um let's move to the lab 4, the last session 3, working with the CPU scene 4 application. Here, first of all, you choose here is the what the menu bar, and you should turn on the debug mode. Okay, turn on the debug mode. This will appear this bar. This bar will contain Go. Is it done everything in one click, step by instruction, step by micro. I don't know. Is there anything different from here? But yeah, I think it's the same thing. And here the fast sequence that show us where what state we are on. We are on, yeah. Here is some state, some basic state that I say to you before. The PC turn on. Yeah, there are some basic state. And okay, about here, we turn it on into binary. Here is the program that in assembly. Here is the register. Here is the main memory. Okay, in the memory there are some stack. You see there are a lot of stack. And here is a it's also you as I say before, memory also contain the program. Okay, right? It's also contain the program. And here is the available program. And also it will be stored in here. Why I can say this? First, let's remember that there are three steps. Three step search cycle, instruction cycle. So instruction cycle is first to sorry decode to execute. Okay, and the last one is store. If we can add this, okay, we have fast decode and execution, but this is important. Okay, and here I will explain to you what happened in this. The the memory have two part, a address and the data. Why the PC know what is the next part? Just already being code, already being programmed. So I don't know. Here we have right here, right? And the first one of the PC or the program counter is 000. And you know program counter contain the address of the start that we will execute. And here is 000. Let's see. Here is instruction is start right end to app. Here, like the first one, we will have data. And here, no address. And here is data. In the first one, we will have. In the first step, we will have the address is 000. Then the data is 0011. The second step we will have. The second tab is jump done, right? Okay. Okay, here nothing. Here, jump done, jump to done. Okay, so the program counter will contain the call 0010. It's already being a program. We just yeah, no, it's there. 1011. The third one is add some to the add some to the add here, nothing. I don't know what it here, what this. Okay, I don't know. Again, here, the add some to the add. Okay, uh, 1011. We have 01 4. Oh, we have it 4. It store some. Store some. Okay, it's me nothing here. Okay, here is store sum. Store the new sum. Okay, we have 0110. And we have here 0010. 5. Here we have jump, start, right? So nothing here. Okay, here. Jump start, go back and write in the next number. Okay? Okay. 1001. And 6. We'll come back to here. Start and write and red. So it will call back the 0, and back. Yeah, just come back, just back to where it's beginning. There's some more. There's some more here. What is this? What is this? Write the final sum. So where is the log sum? Let me see. There's no log sum. What is this? It's me nothing. It's me nothing. Oh, in the 7. Jump start. Store sum. Store sum. Jump start. What is this? It's nothing. Okay, whatever. Now, and I tell you for. Okay, now let's start it. Here is the memory will be the stat that will be executed according to the program. Okay, I don't know the rest contain what, but we are the sum in the 4, in the 3. Oh, in the 3 there are something like this. In the 4, but find the 4 you have assume to the app. I don't know. I don't know. It's gonna take 4. But so where is the here we have stop here. We have stop here. Stop. Stop. And the right. Mhm. Stop. Here. This is some data. Locus and resume store. It's the last one here. Okay, it's enough. It's enough. Now let's start by step by micro. First, as I say here, the main mar, Ah, no, back up one micro. We see you see that there the PC will push the data to the MAR. The data right here is the address. So here, the address 000 will start it will put into the MAR. And now after pushed into the MAR, the main the main here as the at the uh, address the store in the MAR 000 will take execute the data in 0011 into the MDR. Here is the MDR, which stand for um, memory data register. Step by micro. Okay, it's already stored here. And I said before, in the first one is a store the data. No, no, first. Here 0011 and 0011 will be put into the instruction register. We put the instruction register. And the next one is increase the PC, the program counter. And now we end the fact. We end the fact. And now we go to the decode. The decode phase, decode the I instruction register. Step on micro. You can see here it decoded into a demand input integer into accumulator. Here accumulator. And the data here in here, it means start, right? Right into act, right? Into act, and I here, as I say, like in the program, right into act is decode into this, to decode command, command. Okay. Then next is we input, and it will say we will have to I will like what happened? Why did it store? What happened? It just end. It just end. And the first phase decode and SQ. Oh my god, it's already done. And now it's store. Is it store? No, it's haven't store. It have not store. Okay, nice. But it also read into act. It already read into act. It is a content. It's a in decibel. A in binary. 1000 step per micro. Here we come to the next address. The PC will contain the next address A1110, and then it will um here here PC to Mar. Okay, alright. I don't know what okay, but whatever. Here already this will MDR will it's still here. I know the difference between the instruction and the micro instruction. The instruction is you working with one step. You done one instruction, but if you step a micro instruction, you have to write all of this one by one, one by one. I know, yes, one by one. I know step by micro instruction, you have to step one by one like this. Step one by one like this. One by one until you're done the first one. And step one by one until you're done the second one. Okay? Mm, okay, let step by micro. The first the next thing is we store to the what is it? Decimal binary. What does it stand for? I don't know. Okay, just forgot it. Oh, it have more. Have more. It's have more, but I don't know why it's just this. But it's okay. It's okay. Just don't care much about that. Okay. Just there are more in at the rest, but I don't know why it's just appear these two. But it's okay. Okay, it will put into the step here. Hook here, hook here, and then increase the BC to 100. You're here, and then it will cut the instruction um register. We have the instruction here, and let's take a look here what it mean. Jump, done, jump to done. Here, see, jump to done. Okay, and now stop and crawl with the code. With the code, if act, act, it will, there is the stop condition here. The stop condition, skip, skip. Okay. Step by micro. And yeah, it's greater than 0. So okay. Step by micro. It's then the second instruction. I'm sorry. Actually, I have to talk about the instruction first. I will edit this later. Okay. The next thing is okay. I will the piece. I will kind of fastly describe this. Should I take took too much time? Add some more. Okay. Here to execute this instruction, we have to do a lot of thing fast because a skill. Then fast because a skill. Then fast until we got the accent, and then we done it. We did it, but we do it. But yeah, step by micro instruction is took a lot of time to explain. And here we have into the MDR to IR, and then decode. It's mean. It's mean. Yeah, we increase to the 4, but decode is mean. It's mean what? It's mean what? Here we have add some to the app. Add some to the app. Okay, add some to the app. And here we have, it's, oh, okay, after the, okay, 4 to, uh, um, 4 to IR 4. Wait a minute. The 4. It's a 5. It's a 4. What does it mean? I don't know. But ask them to the app. We just know that app. Some to the app. For here. For here. Some ask them to the app. In the 15. What does the 15 mean? I don't. Okay, let's turn it into decimal. Oh, nothing happened. Decimal. Nothing happened here. Wait, wait. Decimal. I have no idea about this. I have no idea about this. But actually, just simply understand that it adds some to the app. Okay. Step by micro. Main mar MDR. Main mar MDR. At the 4. As the 4 is twice with what's here? Memor memor we have, yeah, I don't know. Let's see. Plus MDR to okay. Just add some to the step on micro in decimal. So that there's nothing happen because 0 plus a is okay. Back up one micro, back up one micro, step a micro, step a micro. Because that's nothing happening. There's nothing happening. And okay, we done the sum because there is nothing. There is just one number, so a plus one zero is also a. Turn into being. Okay, let's go. As we'll come to the next one is here. Okay, step by micro is store a new sum. Is store the new sum. Store a new sum. Store the new sum, right? But before it's know that it's store the new sum, it's also have to fetch and the fetch and in the fetch. Okay, it's come to also increase to 1000. 1000. And now it will come to the decode phase. Decode the instruction. Step by micro. This means that store the new sum. Store the new sum. Okay, store the new sum. Okay, we return into decimal to have a easier to look. Sit down. Six. Store sum. Okay, nothing. Stop on micro with MDR. Why restore to the MDR? No. It didn't happen. It didn't happen. Stop a micro. Now it will. Okay, it will push the A to the MDR. As here is still some store a new sum. Store into the MDR. And why store? Where store? Wait, then is it 1000? Where store? MDR to the main mar. The mar right now is one what? Sitting here, and it will store the A into this stack. Okay, you see the start sitting. The start sitting some the data. The location where stem is stored. Why it have two? What is this? 7? Here the A number. Back up 1 micro. Okay, it is sitting. No, it is sitting. Right here, 0. Okay, step on micro. Actually, it stored the sum into the sitting stack. Just easily understand it here. 2 byte location where sum is stored. So it will store in the 7. I don't know why. Actually, I don't understand it. I must, but actually, it will store uh the sum here. The sum is the variable that appear in the start setting, but but um but it 2 pi location where sum is stored. Okay, so it's stored after 2 byte is the 11. 11. Okay. Um, and the next thing we'll step a micro to start. We'll go back. Just redo it here. We already start. Jump to the start. Jump to the start. And now we're back, back, back. Okay, back to 0. And it will doing this in a like a loop, in a loop till the condition stop, get to the stop condition. To the stop condition is thỏa mãn. Reading is done. No, I don't know. It's called is true. Okay. Look to the stop condition is true, and then our stop condition is here. If 0 lesser than. Okay, you know that this is RAM or the memory. First, that is it will store the program, the instruction, and also the output. After that, it also store the result. As I say, that is stored at seven, the seven, the seven stack. Store my 8. Okay, and and now you will get more thing about the register. The register here is like I don't know how to explain it, but it's like the thing that we used to do it. Yeah, it's yeah. As I said before, it's used to contain the um, temporary temporary what? Temporary data. We use it and we move it. We use it and we move it until we get the instruction. Oh, okay. And now let's talk about the step by instruction. The step by instruction that we will do very fast is like just like all the other language that we studied studied um that we've been that we have studied. The compiler will write from the first one to the last one by one, linear, linear order, in linear order. And actually, in this, it just if we talk about step by instruction, it just means that um we explain how the compiler works, not how the computer works. So we want to talk about this. You can step by instruction in other language that you already know. I know how no. Uh it's just step by instruction. It's nothing more, nothing less. And you can hear like okay, I will here. It's coming to the first one, right? A, six. Okay, then it's come to that. It's done. It is say before. As I say before, the instruction cycle contain of fetch equal and a skew, right? Okay, fetch equal a skew, but if we run by step by instruction, it will done everything and give you the instruction after the code. After the code. And we are in here in this way, in this place, in the executing is executing that we are in this state. In this state is more easier to hear. After the cut and okay, like that. Okay, here let's step by instruction. Let's come to the app. Yeah, still at the store, the museum. Go back and rest in the number. And also, like the old one, you take the settings stat. Six. Here the six. Here the six. Or step by micro. Can see that here the six. As you remember, this is this is okay. Step by micro. Step by micros. Oh, sorry. Step by instruction. Cards to I will 8. And I say before 8 to have yeah, yeah. Okay, what is here? Still here? Here is 6. 6 plus 8, we have 14. These are stored in the 7th stack here. To see 14. 14. Okay, that's a simple about step by instruction and step by micro. And okay, the first thing step by instruction have you know know how a program work, and step by micro instruction help you understand how a CPU work, how a instruction is executed, um, know executed, and know more about the process. Okay, now thank you for the